How they come? Well, that's the way we say hello in Eritrea. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of mathematics. Now, children, this picturesque place that you get to see is Danakil Depression, Afar Province, Eritrea. It is a geological wonder where you get to see active volcanoes, hot springs, and salt lakes. Make sure to visit the Dalol volcano, Arta Ale volcano, and the salt pans, which are famous places to visit here. Do have makleel, which is the mouth-watering sweet dish, which I'm sure is going to be something that you've never had all your lives. Make sure to tell all the people of Eritrea that you get to meet how they come. In this note, children, I'll be starting off this lecture but again saying how they come, but at this time it is going to be to proportion. And now, before we start off this lecture, I'll first like to tell you what is a proportion, right? Then we'll be discussing about certain properties of proportion, and after that we'll be discussing an interesting sum. So children, when we talk about, say, two ratios to be equal, right, we call it to be a proportion, right? So let's say we try to write what a proportion is. So if we have some A upon B to be equal to, say, some C upon D, then obviously this can be written as A is to B, which is proportional to C is to D. And this, children, is the representation of a proportion, right? Now, after this, we have certain properties of the proportion. So now next, discussing the properties. Now, children, remember, for all the properties to exist, you should already be having A upon B to be equal to C upon D. And if that is the case, there are certain properties that we'll be discussing. The first property is we talk about invertendo. And in that, what happens is, as we already have A upon B to be equal to C upon D, so if we can say B upon A to be equal to D upon C, then this actually is invertendo. Now, after this, next, children, we'll be talking about alternendo. So in alternendo, what do we have is, remember, we already have A upon B to be equal to C upon D. And then if we can say A upon C, right, to be equal to B upon D, then we call this to be alternendo. Next, children, after this is componendo. I'm sure there must be a question which must be arising in all of your brains, especially Kajol, that why is it that these have such sort of names, alternendo, componendo? That is something that is pretty inexplicable, but whatever it is, they are good to spell, so just learn it that way. Okay, so if, remember, we already have some A upon B to be equal to C upon D, then if we are to talk about componendo, then componendo is what? It is A plus B divided by B to be equal to C plus D divided by D, right? So this is componendo. Now, after componendo, we have dividendo. Well, what happens in dividendo is, the first thing is we already should be having A upon B to be equal to C upon D, and then if we can say in dividendo that A minus B divided by B to be equal to C minus D divided by D, then we call it to be dividendo. Now, children, lastly, we have one very important thing, which is the combination of the last two, that is componendo and dividendo, and that is how we tell it. That is componendo and dividendo. And here, children, remember again what we should be having is A upon B should be equal to C upon D. That is, there should already be an existing proportion. And then if you are able to say that you have some A plus B divided by A minus B to be equal to C plus D divided by C minus D, then this is known as componendo and dividendo. And children, this is the most important property of proportion. Now all of this that I have told you people, I will just quickly discuss. Now here, first thing that I told you people is, if you already have two ratios which are equal, it is said to be a proportionality. And how do we write it? You already know that a ratio is written as A is to B. So A is to B is one ratio, C is to D is another ratio, and as they are equal, that is written by the proportionality sign, that is by these four dots. Now, after we talk about a proportion, there are certain properties that proportions have. That is, if we already have A upon B to be equal to C upon D, or in other words, something like this, that is, a proportionality is there in existence, then invertendo becomes when we make the denominator to be the numerator and the numerator to be the denominator on both sides of the equation. If you watch carefully on the right hand side also, we have denominator upon numerator, right? So this is what invertendo is. After invertendo, we have alternendo. In alternendo, obviously you already should be having A upon B to be equal to C upon D, and then if you can cross multiply this C over to the denominator of the other side and cross multiply this B to the numerator of the other side, so it becomes A upon C to be equal to B upon D, and this, children, is alternendo. Now after this, if you already have A upon B to be equal to C upon D and you talk about componendo, then that is A plus B upon B is equal to C plus D upon D. In dividendo, in place of plus sign, you just have minus sign. That is, if you already have A upon B to be equal to C upon D, then if you have A minus B upon B to be equal to C minus D upon D, then you call it to be dividendo. Lastly, when we combine the last two, we call it to be componendo and dividendo. This is quintessential in doing the sums on proportion. And here we have A plus B upon A minus B to be equal to C plus D upon C minus D, where you already had this A upon B to be equal to C upon D. Now if you watch it carefully, here what is the numerator A? What is the denominator B? So here, what have we written? Numerator plus denominator upon numerator minus denominator. And on the other side, the numerator is C and the denominator is D. So what have you written here? Numerator plus denominator upon numerator minus denominator. And this, children, is what is componendo and dividendo. So all of these are the properties of proportion. Now, using all of these properties, we will try and do a sum, and we will try and get a good idea. And after that, obviously, you will have to practice more sums, and then you will be able to understand this topic really well. So let's get started, children, and let me quickly give you a sum. So this is the sum that I'd like you people to try. Initially, children, I will give you some 10 seconds for trial, after which I'll be discussing the sum with you people. Right, so children, here, if you want to give it a further try, what you can do is you can pause the lecture and give it a bigger try. For that matter, after the solution, the sum is done, I'll expect you people to pause the lecture again and do the sum once all on your own. Right? Okay, now at this time, I am considering this that whatever were the concepts which are just discussed, you've written it in your copies and you've learnt it well. Right? And which is the property that you've considered to be most difficult? Do tell me that. Right? And try deriving all of these different properties. It is pretty simple. Okay. Now here, children, we have been given that we have some x which is equal to root of a square plus b square plus root of a square minus b square divided by root of a square plus b square minus root of a square minus b square. Now, using this, we have to prove also using the properties of proportion, that b square becomes equal to 2a square x divided by x square plus 1. Now in order to do this, children, we get to see that here somewhat we have componendo and dividendo already applied. Just try relating with what componendo and dividendo was. For that matter, I will quickly revise with you people. If say we have some a upon b to be equal to c upon d, then if we talk about componendo and dividendo, right, we will be having numerator plus denominator divided by numerator minus denominator to be equal to numerator plus denominator divided by numerator minus denominator. So here, children, if we apply this, remember the equation that we already have is x, or in other words, we can say that that can be written as x upon 1. As such, we can say x plus 1 divided by x minus 1, and on the right hand side here the numerator is root of a square plus b square plus root of a square minus b square, to which the denominator is to be added now, which is root of a square plus b square minus root of a square minus b square. And now, children, we will be talking about the denominator. In the denominator, we will have the numerator minus the denominator, that is a square plus b square root plus root of a square minus b square. Now, in place of a plus sign, we will now be having a minus sign. So minus times of, we will be having root of a square plus b square and minus root of a square minus b square. Now, children, this is componendo and dividendo applied. Now, if you have a little ambiguity with the left hand side, just look up, you had x here, so obviously x can be written as x upon 1. So the numerator becomes x and the denominator becomes 1, and that is the reason why it has been written like numerator plus denominator, that is x plus 1 divided by numerator minus denominator, that is x minus 1, right? And obviously on the right hand side, you know that we have this to be the numerator, to that we have added the denominator, and from the numerator the denominator has been subtracted in the denominator. Now, children, after this there is a little bit of simplification that we can do. We get to see that here we have this root of a square minus b square, which will get cancelled with minus root of a square minus b square, as both of these are identical but they are additive inverse of each other. Now, if you talk about the denominator, we have here root of a square plus b square, which will get cancelled with minus times of root of a square plus b square, as again both of these are identical but they are additive inverse of each other. Next, if we talk about this, right, both of these are going to get added, as minus minus is going to become plus. Okay, now, children, we will write with what we are left out. So we have x plus 1 divided by x minus 1, which becomes equal to 2 times of root of a square plus b square, as both of these terms are going to get added, right? Similarly, if we talk about the denominator, we will have both of these terms added up, as minus into minus is going to become equal to plus. So thus we will have 2 times of root of a square minus b square. Here 2 is going to get cancelled, and then we now have a root. The best way to remove a root is to square it. So as such, in the next step now, we'll be squaring both the sides. So when we square both the sides, children, next what we are going to have is we will be having x plus 1 divided by x minus 1, and we are going to square the numerator as well as the denominator. And on the other side, what will happen is, as we have a root and we also are going to square, so obviously the roots are going to get removed. So we have root of a square plus b square, which is divided by root of a square minus b square, and here too we have a square in the numerator and we have a square in the denominator. Now, children, if you talk about the left hand side, it is a plus b whole square. Now, if you talk about a plus b whole square, then what it is, it's a square plus b square plus 2ab. And similarly in the denominator we also will be requiring a minus b whole square. And that's what? That's a square plus b square minus 2ab. Right? Now children, here we will be keeping these values as such. Here in the left hand side we have x square, right, plus 2x plus 1, and in the denominator we have x square minus 2x plus 1. Now on the right hand side children, the square and the square root are going to get cancelled, because if say you write something like root a, right, it can be written as a raised to the power 1 upon 2, and further if you square it, it's obviously doing something like this. And since you know that if you have some a raised to the power m which is raised to the power n, then that becomes equal to a raised to the power m into n. As such, here also what's going to happen is you will have a raised to the power 1 upon 2 and 2 getting multiplied, so both of these will get cancelled. As such, this will just become equal to a, that is, neither the square will remain nor will the square root remain, and both of these are going to cancel each other. Now children, on the right hand side here we thus have a square plus b square, which is divided by a square minus b square. And if you see here the left hand side intensely, I get to see something. Kajal, can you see something? Yes, in maths you got to always try and envisage, you always should try and see something so that you're able to do the next step. Can you see something? No? I'll tell you. Here, if say you talk about adding up x square and 1 together to write it as a single term, that is x square plus 1, right, to that is added 2x. Now if you talk about the denominator, you have x square to which 1 is again added, it can be made to be a single term, and from that is subtracted 2x. And on the right hand side we have a square plus b square, and in the denominator we have a square minus b square. So again children, you get to see here that componendo and dividendo has already been applied. That is, if this would have been the numerator, this would have been the denominator. So this is numerator plus denominator divided by numerator minus denominator. And here too, if a square would have been the numerator and b square would have been the denominator, so this is numerator plus denominator upon numerator minus denominator. So in order to simplify such an expression which already has componendo and dividendo, we apply componendo and dividendo once more, right? So let's apply it. So here we can say applying componendo and dividendo. Okay children, now let's see what will happen. Here we'll have x square plus 1 plus 2x, and to that is going to be added the denominator, that is x square plus 1 minus 2x, that is numerator plus denominator. And in the denominator we will have numerator minus denominator, that is x square plus 1 plus 2x, from which is going to be subtracted x square plus 1 minus 2x. Now on the right hand side children, we'll be having again numerator plus denominator, that is a square plus b square plus a square minus b square. And if we talk about the denominator, it is going to become equal to a square plus b square, which is the numerator, minus the denominator, which is minus times of a square minus b square. Now here children, we get to see that there are certain terms which can very easily get cancelled, as they are the additive inverse of each other. Like if you look up the numerator of the left hand side, we have minus 2x and plus 2x, which will get cancelled. Similarly, if you look up the denominator, here we have x square and minus x square, which will get cancelled. Plus 1 and minus 1 will get cancelled. How does this become minus x square? That is because minus sign gets multiplied within. How does this become minus 1? That is because this minus sign gets multiplied within to make it minus 1. Now on the other side here again, there are a few things which can get cancelled. Like we have plus b square and minus b square, which will get cancelled. In the denominator we have a square minus a square, which will get cancelled. And as such here, children, now as I already told you, we get something which is very simple. That is, we get 2 times of x square plus 1, because we get 2x square plus 2. Similarly, in the denominator, we will get 2 times of 2x, as minus minus is going to become equal to plus, so it will be plus 2x. So it is 2x plus 2x, or in other words, we can say that this is 2 times of 2x. On the other side, we will now have here 2a square, as a square gets added up to its like term a square to become 2a square. Then in the denominator, we get b square minus minus plus b square, which becomes equal to 2b square. And as such here, you get to see that 2 will get cancelled from the numerator and from the denominator, and on the left hand side also it gets cancelled from the numerator and from the denominator. Now, as you know that we've got to make b square the subject of the equation, just quickly checking it up. Yes, so very easily now we'll be making b square the subject of the equation. As such, b square can now be written as a square times of 2x by cross multiplication, and in the denominator we have x square plus 1, and thus it can be written to be equal to 2a square x divided by x square plus 1. And let's quickly check whether this is what we require or not. 2a square x upon x square plus 1. Yes, that's perfectly the same, and therefore you can say that this stands to be proved. So children, now I'll just quickly discuss this all over. In the question you've been given here that you have to prove using the properties of proportion b square to be 2a square x upon x square plus 1, when you've been given that x is equal to root of a square plus b square plus root of a square minus b square divided by root of a square plus b square minus root of a square minus b square. Now children, here what you do is, if you consider this x to be actually x upon 1, then on the right hand side it looks as if we have componendo and dividendo already applied. For that matter, quickly revising with you people what componendo and dividendo is, if you already have a upon b to be equal to c upon d, then componendo and dividendo is numerator plus denominator upon numerator minus denominator, right? And on the right hand side again you will do the same, that is numerator plus denominator upon numerator minus denominator. Now applying this to our existing equation, right, which is actually x upon 1, so we can say that numerator is x and denominator is 1, so numerator plus denominator becomes x plus 1. Numerator minus denominator will thus become equal to x minus 1, right? And on the right hand side, very simply, we will just add to the numerator the denominator, that is root of a square plus b square plus root of a square minus b square, to which is added the denominator, that is root of a square plus b square, right, minus root of a square minus b square, right? And here we get to see that plus root of a square plus b square gets cancelled with minus root of a square plus b square. In the denominator, it will be the numerator minus the denominator. So this is the numerator, the same as above, minus times the denominator, which is the same as this. Now here we get to see that plus root of a square plus b square and minus root of a square plus b square, when this minus sign gets multiplied within, are going to get cancelled, and this term minus minus is going to become equal to plus, so it will become root of a square plus b square plus root of a square plus b square, or in other words 2 times the root of a square plus b square. In the numerator also we have root of a square plus b square, which gets added to root of a square plus b square to give us 2 times of root of a square plus b square. Now children, if we square both the sides, we will now have here this root removed. On the left hand side we will get x plus 1 whole square divided by x minus 1 whole square, and on the other side we'll have these root terms squared. Now whenever something has a root and you square it, then obviously the square root vanishes. How so? If you have some root of a and you also have the square of it, then root of a can be written as a raised to the power 1 upon 2, whose whole power is 2. Now by the rules of indices, we know that a raised to the power m whole raised to the power n will become equal to a raised to the power m into n, and that is the reason why here what will happen is the power of a is 1 upon 2, and it will get multiplied with the 2 here, as m is 1 upon 2 and n is 2, right? And thus the power of a will become equal to 1, right? And thus the root gets removed from the right hand side, and thus we can just say a square plus b square upon a square minus b square. And on the left hand side, we are now to write something like a plus b whole square, which becomes equal to a square plus b square plus 2ab, right? And by another algebraic identity, you can talk about the expansion of x minus 1 whole square, that is a minus b whole square. So that becomes equal to a square plus b square minus 2ab. Now next here, what we do is we now talk about writing the expansion. So it becomes x square plus 1 plus 2x, right? And similarly, the denominator becomes x square minus 2x plus 1. Now children, there is something to note here, that is, if we keep x square plus 1 together and 2x separately, similarly in the denominator, if we keep x square plus 1 together and 2x separately, this can be written as numerator plus denominator upon numerator minus denominator type, and we also have it the same way in the right hand side. And like I told you, when you have such sort of expressions, it's best to apply componendo and dividendo once more. So we apply componendo and dividendo once more to simplify this. Thus, we will have numerator plus denominator, right, upon numerator minus denominator. That's why this minus sign is outside, right? And on the right hand side also, numerator plus denominator divided by numerator minus denominator. And that's why this minus sign is again outside in front of the denominator. Now children, here we find that there are few terms which will get cancelled, as plus 2x will get cancelled with minus 2x, and in the denominator we will have x square which will get cancelled with this x square, as this minus sign will get multiplied to plus to become minus x square. Similarly, plus 1 will get cancelled with minus 1, as this minus sign gets inside, gets multiplied with 1 to make it minus 1, right? So plus 1 minus 1 cancels, and minus minus will become equal to plus, so it will become 2x plus 2x, or 2 times of 2x, right? In the numerator we have x square plus 1, which comes again, so we can write here 2 times of x square plus 1. 2 gets cancelled. Similarly, on the other side, we have plus b square and minus b square, which will get cancelled, and thus we have a square plus a square, which will make it 2a square. In the denominator, we have b square minus minus plus b square, which will make it 2b square. So 2 will get cancelled from the numerator and from the denominator. Now children, our task is to make the b square the subject of the equation, as we require an expression with b square. So here we get to see that there is b square, so we will just make it the subject of the equation, cross multiplying this b square to the numerator of the left hand side. We'll have b square to be equal to a square times of 2x, right, divided by x square plus 1, so that we can make b square the subject of the equation. Now this can obviously be written as 2a square x divided by x square plus 1, and children, this is what we were required to bring for the value of b square, that is 2a square x upon x square plus 1, and therefore this stands to be proved. So is everybody clear about this? Kajol? Sure. Kajol, I think you're still not thinking about that sweet dish that you go and have when you go to Eritrea. Do you remember its name? It's maklil, right? And it's really fantastic. But at the moment, you've got to do the sum, right? And after the sum has been explained now, I expect you people to pause the lecture immediately and do the sum all on your own. Make sure not to use any abbreviations like C and D. Do write it in full, that is componendo and dividendo, as you are expected in the board examinations, so that any examiner from any state looks up your copy has to give you full marks, because that is perfectly correct, right? So children, this is all that I have for you people in this lecture. I hope you people have liked this lecture and have been able to understand what proportion is, what are the different properties of proportion, and have also understood this slightly complicated sum on proportion. So bye children, do study maths and have a nice time. Bye.